That pandemic has struck again. For the second year running, our great international microscopical conference in Chicago has been forced to cancel. Though that doesn't mean, as many of you have pointed out, that I can't do my annual evening with Brian. This year we're going to look at the pandemic, and are we ready for the next one? I'm going to start by looking back to the discovery of the coronavirus, which I remember very well, and remind us of some of the women scientists who were crucially involved in that important area of research. Then we're going to look at the introduction of biohazard law, the construction of safety regulations for the proper handling of viruses. Then, face masks. I'm going to show exactly what is the science of face masks and whether they really can work in the way that we're told they must. And a series of demonstrations of virus size. Few people really understand how small a virus is, and this, for the first time, will show you exactly what the proportions truly are. Then we move on to find a novel way of reducing transmission. It could cut the rate of virus transmission in half, and then consider how hospitals, and indeed the apparatus and equipment we use in hospitals, could be improved to prevent transmission of viruses in the future. Because let's face it, it's not a question of if there's going to be another pandemic, but when. The next one is waiting for us just around the corner. Nobody knew how serious the pandemic would turn out to be. The virus could easily have been carried on shopping. In March 2020, I realised that people needed a precautionary protocol to try and keep safe. We have some apples dropped off on our delivery shelf. How nice. They're handled in latex gloves. The apple wrappings go straight into the bin, and so do the gloves. That one is peeled off, that one is peeled off, and they go too. And now we go to wash our hands. That does seem rather over the top in retrospect, I agree. But at the time, nothing was known about this disease. We didn't know how infective it was. We didn't know how dangerous it was. To science, it was all new. The first person to recognise the coronaviruses was my late colleague David Tyrrell, head of the Common Cold Research Unit in England. He called it B814, and he told me all about it in 1966, when he had an office not far from my home. The same virus was also being studied at the University of Chicago by Dorothy Hamray, a virologist who's almost been forgotten about, though there are some records in the Klein Library at Northern Arizona University. The enduring problem of how to see the virus was solved by June Almeida, a brilliant electron microscopist who never even went to college, and who was eventually awarded a doctorate on the basis of her important discoveries. And these were the pictures that Tyrrell showed me so excitedly. They were eventually published in the Journal of General Virology in 1967. The name coronavirus came from the halo that surrounds the virion. Each looks like a corona. I had first cultured viruses in 1960, when I was on the staff of the Medical Research Council, in the most junior capacity you could possibly imagine. We used HeLa cells and monkey kidney tissue. But all the time this work was going on, I was perplexed by the fact that there seemed to be no legal basis for this work. There was no safety code. There was no law governing the way in which germs and dangerous viruses should be handled. And that led me to start a campaign that led to the introduction of biohazard law. In the 70s, I knew personally a number of politicians. Here I am with Prime Minister Harold Wilson, when I was demonstrating my research at the Royal Society in London. Edward Heath was a Conservative Prime Minister, and this photo was taken at his home when I was making a television programme about the Channel Tunnel. And this is with Neil Kinnock, Labour leader. We knew each other since student days. I had so many discussions with politicians at all levels, and also with fellow biologists. And in the end it was agreed that private discussions weren't enough. What we needed was a public campaign for biohazard law. My public campaign for biohazard safety began in 1973 with articles in the Times in London. I'd first published my proposals in 1971 in the New Law Journal, and it was the subject of a leading article I wrote for Nature in 1974. I took part in the BBC's flagship TV programme Panorama, startling their presenter with a sealed culture of typhoid I produced from my pocket. I pointed out there was nothing to stop me doing that legally, though if the bacteria had been in my gallbladder and not in a culture bottle in my pocket, I could have been detained by the police. When my campaign began, there were no legal controls on the safety of viruses, no matter how dangerous they were. It was my Nature paper that was crucial to the campaign. I proposed that there should be categories of pathogen, Schedule A for those posing greatest risk to human health, and Schedule B for the conventional pathogens we encounter in our daily lives. Research staff should be properly trained and their premises officially approved. It was in the United States that these proposals first took root. They added a category at the bottom end for innocuous organisms and another at the top for things like Ebola. So the official biosafety regulations governing medical laboratories recognise 4 categories of pathogen, from the harmless to the devastating. The British authorities were slower to act, but in 2002 the regulations governing the control of substances hazardous to health agreed that there should be 4 groups of pathogens. It has always seemed most likely to me that the obvious source of the escape of the virus was the Wuhan Institute of Virology. And the sense of self-satisfied, smug hubris is everywhere as we point the finger of blame. But be careful. Recently, 8 mice, likely infected with the SARS virus, escaped from the laboratory at the University of North Carolina. 75 people were exposed to anthrax at the CDC. 6 mislabeled vials of smallpox virus were discovered at the FDA. Virulent strains of Burkholderia cultures were released in New Orleans, and that in the space of a single year. And where was the last fatal case of smallpox? No, not in Africa or some obscure corner of Asia. It was in Birmingham, England, as a result of smallpox virus escaping from a laboratory. There's little point in having regulations unless people follow the rules. You can find resonances of my biohazard proposals in laws all around the world now. And the whole thing is exemplified by one symbol above all others: the face mask. There isn't a country in the world which doesn't insist that everybody wears a face mask. The information leaflets in every country I've ever encountered insist on the safety that a face mask alone can provide. As a precaution against large droplets, they are certainly helpful, but the message the public is being given is that face masks protect against the coronavirus, and that message is everywhere.
The surgical mask consists of material that has a very high ability to filter out small particles such as bacteria and viruses.
Here's how you can make your own face covering in a few easy steps.
America's top medic, showing how all kinds of household items can become a mask. It's a massive shift in policy.
And you have yourself cloth face cover.
The ridiculous idea that a piece of cloth or even a face mask can hold back virus particles continue to dog our heels at every turn. And the one thing everybody kept asking me was, how small is a virus? So in March 2020 I compiled a hasty video to show how you could relate the size of viruses and bacteria to everyday objects. How small is a virus? So let me show you something which is easy to follow and which isn't available anywhere else in the world. After this little introduction, you really will have an idea of how small a virus truly is. Let's just take a leaf. Under a hand lens, you can just see the speckled pattern of living cells. The living cell is just beyond normal eyesight. If you've got very good eyes, you might see it with the naked eye in the sunlight. Otherwise, a little lens will allow you just to see the cells of which it's made. If you look closer, you can definitely make them out. So, do you have in your mind's eye how big a plant cell is? It's just possible you might see it. If not, it's only just beyond the limits of your sight. That is the size of a plant cell. Okay, then if the plant cell is the size of this chair, a cell in your body is as big as this cushion. And if that cushion is the size of a cell in your body, then this carefully dried olive is the size of a bacterium compared to the cell. And if the olive is the size of a bacterium, then these little fenugreek seeds are about the same size, proportionately, as a large virus. So there is the size comparison you seek. There's your virus. The olive represents a bacterium. They're both sitting on what might be a human cell, and that human cell is nestling inside an armchair, which corresponds to a plant cell, the smallest thing you can possibly see with the naked eye. Oh, please ignore the cheetah. He just lives there. So there you go. Olive and fenugreek. The clue to understanding how small bacteria are and how much smaller are viruses. So now it's time I took you down the microscope so that you can see what these things actually look like. I was showing you the structure of a leaf under low magnification. To see the cells in greater detail, we need to turn to a higher powered microscope. This time we'll take a little square of the leaf and look at it under a compound microscope. Now we'll switch to high power. We can see the little green discs inside each cell. Those are the chloroplasts, with which green plants capture the energy of the sun and convert it into sugar. Science can't do that. Isn't that a thought? Humans are unable to imitate what is done by every leaf of every plant growing your garden. Now we can look at human cells. These are the cells that line your cheek. They're stained purple to make them easy to see. In the middle you can see the nucleus, and those little purple stained dots all across the cell, they of course are bacteria. Your mouth is full of them. They help to keep you healthy. Now, you can't see much detail of bacteria under a light microscope. They really are too small. They're about the smallest things you can see. To see details of bacteria, we need the scanning electron microscope. I don't happen to have one of those here, so it means going to see my very good friends at the Cavendish Laboratory in Cambridge. University of Cambridge, the Cavendish Lab. So here we are in the lab, and we can now look at the fine detail. That's much better. These are E. coli under the scanning electron microscope. I know you think of E. coli as being nasty, but they're necessary for life. 1/3 of the contents of your bowel by volume is E. coli. E. coli is our friend. Using a transmission electron microscope, colleagues in America have taken these fine pictures of the coronavirus. Called a coronavirus, here are 3 of them, because they rather look like crowns. There's a circle with jewels scattered around the outside. This is all we can see through the microscope. The detailed impressions of the virus that you see everywhere in the media, those are CGI, computer-generated images of what it might look like. This is all we can actually observe. So even with the best microscopes in the world, we can only just glimpse what the coronavirus particle looks like. There are several of them. Some coronaviruses cause common colds. We all have them. Several produce diseases so mild that you'd hardly know you were ill. And then, of course, we have the SARS viruses, like the SARS epidemic of 2003 and today's epidemic of SARS, which for some bizarre reason, like text speak, they've decided to call COVID-19. Even to a microscopist, it is remarkable to think that something so diminutive, at the very edge of our perception, can cause so many problems in so many places, and so much tragedy for so many people. The diminutive dimensions of a virion continue to dog the heels of the argument at every turn. I have always been convinced that a face mask cannot intercept a virus. And I'm not alone in that view.
We don't recommend them for the general public. In fact, it could have the alternative, undesired effect of transmitting these infections more readily to the untrained wearer.
Medical masks like this one cannot protect against the new coronavirus when used alone. If you do not have these symptoms, you do not have to wear masks because there is no evidence that they protect people who are not sick.
If you are healthy, there is not thought to be any additional benefit to wearing a mask yourself because the mask is not airtight and does not necessarily prevent breathing in of these viral particles, which are very tiny.
These so-called surgical masks, they're in essence made of paper, widely touted as protecting against viruses, but in practical terms they're pretty well useless. I made the point in a video that I recorded in rather scathing terms in March 2020. A lot of people have said, those paper face masks that the NHS have been issuing, are they useful? No, of course they're not. They're no bloody good at all. Well, they may cut the risk down by, say, 5%, but you need hermetically sealed masks, and at the moment, those are in desperately short supply. So, how can you catch it now? Well, you're not going to avoid catching it with a paper mask. You're not going to avoid catching it by freezing anything. Remember, we freeze germs and viruses to preserve them, so freezing won't do any good at all. You can also catch it by the expedient of being in hospital with something else. There's a case to be made for all the COVID-19 patients to go to the special new hospitals. Putting them in ordinary hospitals means that people already ill are exposed to a second hazard, and that makes no sense at all. But there is a comparison, you know, to help us keep this in proportion, with the influenza epidemic that followed World War I. In 1918, more people died from the flu epidemic than had died in the whole of the war. We all know that statistic, but let's put it in proportion. The world's population in 1918 was 1.8 billion. The number of people who caught the flu was 500 million. So for every 2 people who caught it, there were 7 who didn't. So there isn't any reason to be unduly frightened. The chances are you're not going to catch this. And if you do catch it, the chances are you are not going to die. So, how do you catch it? One method of transmission is, of course, contact, which is why we were always told we must be sure we wash our hands. You shouldn't shake hands with people, though not everybody, I seem to recall, has followed that advice.
I'm shaking hands continuously. I was at a hospital the other night where I think there were actually a few coronavirus patients, and I shook hands with everybody. You'll be pleased to know.
And indeed, neither should you touch your face unnecessarily. Now, it has been said that you should keep 2 meters apart from anybody else, and that's because in the still air of a laboratory, droplets normally spread about 2 meters, 7 feet or so, around you. But it's a ridiculous thing to tell people because it depends on how the air is moving. If there is a drift of air from right to left, then anybody downwind of you is going to catch it if they're many, many meters away. And somebody half a meter upstream is unlikely to catch it. Not only that, but you have to remember that most of these how far can you go experiments have been based on bacteria in droplets of spittle. Now, bacteria are a lot larger than viruses. If you picture the COVID-19 virus, for example, as a Malteser, then a typical bacterium, like the Staphylococcus that you will find causing boils or sometimes gives you a sore throat, is the size of a football. So a virus is very, very tiny. And I have no doubt that viruses can sit in aerosol suspended for a very, very long time. It should also be said that COVID-19 is a really stupid name. This is SARS, Severe Acute Respiratory Syndrome. It is SARS Mark II. Do you remember SARS in 2003? Well, this modern virus has 80% of the same genes. It is SARS Mark II. Now, if you think back to SARS, which peaked in 2003, altogether, SARS infected 8,000 people. It killed 774. Now, the point about the new version of SARS, SARS coronavirus 02 is that it is far less lethal but far more infectious. It is 10 times less likely to kill you than the SARS of 2003, but it's about 3 times more infectious, and that is why we've run into the problems that we have. One person infected with this COVID-19 can infect, on average, 2 or 3 others. Polio or smallpox would infect 9 others, which is why they were so incredibly infectious. And if you want the world record for infectivity, then that would be measles. Measles is a disease that still kills people. And one person suffering from measles normally infects 15 or 20 others. It's the most infectious virus that we know. By the way, people still insist that measles vaccination is dangerous. Measles vaccination saves an awful lot of lives. And I'll bet those people who've been clamouring, campaigning against vaccination are going to be queuing around the block as soon as there's a vaccination for this new disease. So let's keep it in proportion. If you're old and at risk, someone like me, then you do need to do everything you can to avoid it. But most people are not going to contact the virus. Of those who do, most people are not going to get ill. Of those who are ill, most people will not get seriously unwell. And of those unfortunate enough to end up in hospital, most will not die. This is a virus we need to avoid, but it's not the end of the world. Remember, this was all filmed in March 2020, when nobody had any real idea of what we should be doing. Even so, the official instruction everywhere is that face masks must be worn. They will protect you against viruses. In a video I compiled in April 2020, I looked at the background to all this. And the best I found was a professor insisting that you shouldn't even take a mask off to eat a meal. Truly, matters had gone beyond a joke.
Wearing a mask must be consistent. It's not on to wear a mask and then decide to take it off to smoke a cigarette or to eat a meal. It must be worn full time.
I am not the only one to have a little joke about face masks. These websites are a joke too. They are fake. Many of these sites simply take money and never sell any goods. They claim to be based in Europe, but they're actually in Cameroon. And even if the websites aren't fake, the goods can be. There are counterfeits everywhere. So, you can't rely on the web, you can't rely on the goods, and often, you can't even rely on the evidence. This graph is often brought out to suggest that wearing face masks made a difference. In South Korea, as in Japan, and in Singapore, cases of COVID-19 were well controlled because they, like the people in Hong Kong, often wear face masks. But this omits a crucial fact. The place that had more cases than anybody else was China, and the Chinese people are the world's leaders for wearing face masks every day in the street. They've worn them, as a matter of course, for decades. They have worn more masks than anybody else. I spoke on this in Chicago in 2009.
Our first speaker today is Brian Ford, who's going to be speaking on hidden avenues of infection.
I was lecturing on diseases and mentioned the face masks in China in my talk.
Face masks are great for people wear them because they believe they protect against traffic fumes and also against airborne pathogens. These face masks are not being worn because there's been an outbreak of anything. They're quite commonly worn day to day by people travelling to work.
Plenty of people take the wearing of face masks and protective clothing very seriously indeed. On March the 11th, 2020, these photographs were taken at Los Angeles International Airport of Naomi Campbell, who is well known as a person who wears weird protective clothing. These biomasks actually claim to be antiviral. Well, we'll see how reliable that claim might be in a moment. And here's a chap with "Stay safe" written clearly, the motto of the moment. If you're fully gowned up to resist the onslaught of a virus, then this is how you look. I have to say, if somebody turned up to nurse me looking like that, it would scare the shits out of me. Let's look at these hospital staff, fully prepared in different ways for the task of caring for patients whom they know will be highly infectious. In present-day terms, these women seem well prepared. Any official or politician or, dare I say it, conventional microbiologist would probably regard these women as in full armour and well prepared for the task that lies ahead. But to me, it tells a very different story. First, those gloves. People love gloves. Shop staff wear them when they serve you cheese or when they slice the meat. Cleaners and cooks wear them. There is a family in America, who I believe once had attachments to our own royal family, who insist that their staff wear these gloves all the time. So where's the problem? Gloves carry germs. Germs adore gloves. Pathogens travel from place to place on them, and the humid environment of the hands trapped inside gives germs the very chance they need to reproduce like never before. To germs, gloves are like a package holiday to paradise. Gloves also leak. It depends on their thinness, but 30% of some brands let germs in or out. The idea of wearing gloves is to protect against germs, but the way they're worn has the opposite effect. The organisms on this woman's face will find a new home on everything she touches, and anything she touched earlier will already be on her face. Her spectacles pose a problem. A visor will stop anything splashing directly into her eyes, but if her spectacles slip down her nose, or they aren't comfortable behind her ears, there is nothing she can do to adjust them. That's just irritating. Then there is the hair question. Hair harbours every kind of particle that floats in the air. She already has a community that derives from where she lives. Shortly she will be carrying countless teeming numbers of every airborne organism or virus from everywhere she goes all day. Similar comments apply to the other woman too. Her visor is more open, and it does nothing to stop airborne droplets or aerosols from wafting up and into her nose and eyes. Some viruses, coronaviruses among them, can enter the body through the eyes. The eyes need protection in a contaminated environment like a hospital ward, and this visor does not really provide it. And finally, those masks. In an earlier video, I wasn't very polite about them. They're no bloody good at all. Well, they may cut the risk down by, say, 5%. My suggestion that they probably stop only 5% of transmission may not have been fair. It could be a reduction of 8% or even 10%. But the sense of security these masks provide is largely an illusion. The masks do not fit tight against the skin, and even if they did, they are powerless to hold back viruses suspended as aerosols in the air. Most masks can hold back water droplets, and many can hold back bacteria. The reason they can't hold viruses back is simply a question of size. If you recall my little analogy of the olive as a bacterium and the seed as a virus, it's the size that makes all the difference. A mask may be very good at holding back the bacteria, but when it comes to the viruses, it has no effect at all. Yeah, viruses really are too small for masks. But if you want to wear a face mask, by all means do. At least you can be confident that you're not coughing on others and nobody else is gobbing all over you.
This is how COVID-19 is spread. Through air.
Schlieren and photography can show how air escapes past a face mask.
That mask has to fit. This is almost like not wearing a mask at all.
My name is Desiree Whitmore, and I'm a teacher here in the Teacher Institute. Even when I talk, a lot of breath comes out of my nose. So this is a mask that I made at home, even though
this is an important demonstration which compared a whole range of masks. Once again, we see that a large volume of the wearer's breath escapes from round the mask.
Face, you can still see a lot of my breath coming out above the mask. Each and every one of these masks did allow some of our breath to escape.
Schlieren pictures are complex and costly, but there is a simpler way.
Now we make it visible because we're in a colder climate.
Chad Roy is a moisture and mould expert from Vermont. He just uses cold air to prove the point.
Here's one.
The spillage of air past a surgical mask is evident.
Here's two.
Even when you double up, the effect is much the same.
Next, we're going to try a cloth mask.
There's little evidence in this mask's favour.
Next, we're going to try an N95.
This is the top grade mask that medics use to eliminate virus transmission. But does it work? Nothing suggests it does. Yet the pressure to make people believe in masks is overwhelming. If you cast doubt on the official recommendation to wear them, is listed under the heading of misinformation. Truly, an objective discussion in this modern era is becoming increasingly difficult. The idea that wearing a face mask will protect against infection dates right back to the 1400s and the Black Death Plague. These strange bird-like masks were worn along with protective outer clothing to protect doctors from catching the plague. The nose piece was filled with lavender or a kind of potpourri, the belief being that the fragrance would keep the germs at bay. Indeed, you can still buy the masks on eBay for a few dollars. We laugh at these superstitions now because we know they don't work, but believe me, one day soon people will be chuckling about our misplaced faith in face masks. The people who say that wearing face masks can help reduce virus transmission are perfectly correct. But those who say they keep you safe are wrong. And after modelling microbes with olives, I thought in April 2020 it was high time we moved on to look at something real. This is the appearance of a popular fabric mask under the low-power digital microscope. Each aperture is 1/4 millimetre in diameter. If we mount a portion on a prepared slide for examination with a research microscope, at 50 times magnification, we can discern the essential structure of the fabric. Increasing the magnification to 100 times, we can clearly make out the polyester fibres from which the mask is manufactured. However, the specimen was not mounted on a fresh slide, but superimposed on a crystal violet stained preparation of bacilli, several microns in length and 1 micron across. Magnified some 750 times, we can easily comprehend the ratio between the size of the cells and the fabric fibres. We can add red circles to pick out a single bacillus on the right. On the lower left is a bacterium undergoing binary fission. Now we magnify over 1,000 times, and here we can clearly see a few stray fibres from the mask, and behind them the bacilli. Clearly, they are unlikely all to be intercepted by a fabric face mask. An enlarged micrograph takes us past the resolution limit of the light microscope, and now I'm adding the image of a 100 nanometer coronavirus particle. Can't make it out. Here it is. In May 2020, an article on research at the Centers for Disease Control and Prevention in Atlanta, Georgia, Scientific American published a view of viruses in airborne droplets. Is it realistic to think that such diminutive structures really could be intercepted by a cloth mask? It's a ridiculous idea. Even those aerosols are minute compared to the huge holes in a fabric face mask. So I decided to put some figures on it, because it's mathematics that proves the point. We measure microbes in microns. A micron is a millionth of a metre. The bacteria that give you boils or a sore throat measure 1 micron. A sturdy hair is 100 microns thick. Here's a close-up photo of some stained bacteria, each measuring 1 micron across. The size of the coronavirus particle is arrowed. Now, to appreciate just how small it really is, we're going to drop it onto a bacterium and see how many stretch across the cell. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Viruses span 1 micron, the width of that bacterium. So how many bacteria reach across a polyester fibre from the mask? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, each fibre measures 10 microns thick. And here is a fibre alongside a very fine human hair that's 50 microns across. 1, 2, 3, 4, 5 fit across the 50 micron hair. And how many hairs does it take to span a hole in the mask? 1, 2, 3, 4, 5, 6. Well, that's an elongated hole, so it's safer to say 5. 5 times 50 equals 250 microns, a quarter of a millimetre, which is the size of the hole. So we multiply 10 viruses on a bacterium, 10 bacteria on the width of a fibre, times 5 the width of the hair, multiplied by 5, and you can see that it takes a line of 2,500 coronaviruses side by side to reach across a single hole. In the size of a hole in this mask, you could pack 5 million coronaviruses. And so to my final demonstration, I decided to relate the size of the virus to something with which we're all familiar. You can only see these things clearly through the scanning electron microscope, and I had all the images I needed on file. So I prepared a composite video. Since a hair is just about the finest fibre you can see with the naked eye, I thought, well, let's start there. Here is a human hair. It takes 10 of them lying side by side to stretch across a millimetre. Here is what that single human hair looks like under the electron microscope, and I'm now adding images of 3 red blood cells on it to show how small they are. Remember, that hair is 1/10 of a millimetre across. So now, this will be divided into 10. The 3 red blood cells are still there. And I will take this central example and we'll split that again into 10. This strand is now 100 times smaller than the width of the hair, so we'll move in to take a closer look. The blood cell looks more prominent on this scale. Alongside, we can see some much smaller features, and the strand thereon has itself been split into 10. This is where we encounter bacteria. These are streptococci. They grow in chains like a necklace. Some species make us ill, from sore throats to pneumonia. Other species make yogurt. Next to them are bacilli. They grow end to end, like a string of sausages. Some species make cheese. This curved bacterium is the kind that causes cholera. It has a single flagellum with which it swims. Some bacteria, like the E. coli that lives in your intestines, has lots. And these are staphylococci, staphs. They're normally harmless, but can cause anything from boils to septicemia. So now we'll magnify more. We come in closer until the field of view is dominated by those bacteria. But what's this we can see? This last splitting into 10 takes us down to 1/1000th of the width of the hair. And this is the realm of the coronavirus. Minuscule rounded bodies, each 1/1000th the width of a human hair. They lie at the edge of life. They're now magnified as much as the width of the hair with which we began. And if you want to see the ultimate germ, the smallest we know, then here it is, the virus MS2. It's roughly as big as a prion. These tiny agents are too small to contain any genetic material. They cause diseases like bovine spongiform encephalopathy, mad cow disease, variant Creutzfeldt-Jakob disease, and Gerstmann-Strauss-Scheinker syndrome. I'm sorry, I'm just showing off there. But these little things are so small they're about 100 atoms wide. These viruses on your television screen are about 2.5 million times larger than life. If a coronavirus is as big as a lentil, then size for size, the holes in a fabric face mask are the size of a railway tunnel. Even if you had an aggregate of thousands of viruses, it wouldn't be bigger than a tennis ball. And so far as the tunnel is concerned, the tennis ball is not likely to be stopped. In my critical focus article, I listed the many factors that can help masks stop viruses. Viruses can settle through gravity. They can impact fibres and be adsorbed onto them. Even lock on through static electricity. But even the best face mask isn't up to the task. In December 2020, I made a composite micrograph of an N95 face mask, the best available. My picture showed just how open is the structure of a face mask, even an N95. I showed a red and a white blood cell, and some bacteria, and the tiny coronavirus particles, which wouldn't be stopped by anything like this. The picture was selected to go onto the front cover of the journal. It does put matters into perspective when you realise that trying to stop viruses with a face mask is like putting a hedge around your garden to keep out the ants. Let's face it, during a pandemic, the air in any enclosed space becomes heavily contaminated with droplets containing virus particles, and we all know what happens to them. What everybody is certain about is what eventually happens to the droplets. They settle out, and you encounter them on every surface, everywhere you go. In every infected closed space there will be virus on the surfaces. You'll touch a doorknob, you'll touch a finger plate, perhaps a door handle. Everywhere there are viruses. No wonder everybody tells us to wash our hands. So you head to the bathroom and you run a lovely sudsy bowl of warm water. Then you wash your hands for the correct length of time. Dry them off in a nice fluffy towel, knowing that as you leave the bathroom your hands are completely free of any coronavirus. Hang on, we're touching the door handle again. I thought we'd agreed it was covered with virus. And indeed, the moment you've left that bathroom, everywhere you go, you're going to be collecting more and more virus. You're touching doorknobs, push plates, chair backs, door handles. Within a minute of washing your hands, they are once again contaminated with coronavirus. Washing will inactivate any viruses on your skin when you're in the bathroom, but it's a much better idea to avoid contacting the coronavirus in the first place. I have a unique answer to keeping the virus at bay, namely thin cotton gloves, the kind that jewellers or antique dealers or document specialists wear to protect something special. I never go anywhere without them. Infections through contact was originally believed to be the main means of contracting COVID-19. When you're out on public transport, half of the contact comes from handrail. With new genotypes appearing in many countries, it is increasingly important to limit transmission. Cotton gloves could cut the rate in half. Cotton gloves allow you to keep the virus off your skin in the first place, which is much easier than trying to get rid of it later. Latex gloves encourage bacteria to breed on your hands, and they also spread microbes from one place to another. But cotton gloves are just what you need. They insulate your skin from the outside world, and they minimise the spread of pathogens.
Professor Brian Ford, microbiologist, is here. Hi, Professor. It's nice to talk to you.
I mentioned the idea in an interview with Andrew Easton for the BBC on the 21st of September 2020. And a significant proportion of cases are transmitted by touch, by people holding a handrail or a doorknob or something like that, the edge of the bar if you go to buy a drink or wherever else it may be. I would recommend people to start wearing those cheap disposable cotton gloves, the kind that you use to look at old books and rare jewellery. You can buy them very cheaply. The price will go up now I've said this. But in fact, if you wear cotton gloves, that will cut down your chance of picking up things.
So the essence of what you're saying then is keep a distance from people and also reduce your hand contact that pass the virus on to your face.
It is also briefly mentioned in my most recent book. My novel little notion is going to appear in my next column for the Microscope journal, and I've already published it with the British Medical Journal in London. If you wear cotton gloves, then you can stop your hands from coming into contact with the coronavirus in the first place. And believe me, if you can keep the virus off your skin, you do yourself a lot more favours than if you're vainly trying always to get it off again. I have long been convinced that there must be a better answer to keeping people safe. So in April 2020, I filmed a novel solution to that enduring problem. If there is one major area of concern about the way that we care for the patients tragically afflicted with COVID-19, it's been the lack of PPE for the staff, personal protective equipment. Some were even reduced to trying to use bin bags as a way of avoiding infection. And we have to accept that face masks never work as well as people would like us to think they did. So in this video, I'm going to try and find one possible answer. Now, you won't mind my saying that PPE is not an acronym. An acronym, by definition, from the Greek, must be a word, like NATO. Yet, thousands of reference sites persist in getting this wrong. CERN is an acronym. Most of what they list isn't. There's actually a joke among managers. What you need is TLA, they say. And when you ask, what does TLA mean? They say, 3-letter acronym. The entire joke is wrong. TLA can't be an acronym because it isn't a word you can say. Laser is an acronym, so is IKEA, but BBC isn't, nor is FBI. They are abbreviations, and the same is true of TLA and PPE. The problem isn't just supply, but efficacy. Many people hate wearing this stuff anyway. In most industries, we see staff just won't wear protection. When it comes to face masks and the public, most agree that that is a matter of personal choice.
If people want to wear a mask, that is okay. It protects others more than it protects you because it prevents you from breathing or speaking moistly on them.
Masks may be able to control moistly speakage, but they don't control viruses. Masks cannot work as well as people claim. No such filter can stop a virus, and the wearer's breath spills out from the sides. Masks are inconvenient. They muffle speech, and when you're wearing the whole kit, they terrify the patient. There must be something better, a complete rethink from the start. It must be lightweight, but will guarantee to prevent all germs from getting to the wearer. Fungi, spores, bacteria, viruses, prions. Visors restrict vision, so we need something with an uninterrupted all-round view. Masks can cause a feeling of claustrophobia. They are not always easy to take on and off, and they limit easy breathing. For everyday masks, there are only a few centimetres between the wearer's mouth and the air in the theatre or the ward. There should be 10 times as much as that. It isn't always easy to wear spectacles or to adjust them, and it's impossible to use a phone. We want something that isn't tight on head or face, no straps or buckles to adjust, nothing confining, cheap to manufacture, and offering pure, fresh air, not germ-laden air from the ward. Ideally, one device should be wearable by anybody, and it shouldn't fog up with condensation. So let's picture an idealized situation to see if we can find a new answer. So here is the patient, sleepy perhaps, or just relaxing. The bed is conventional with its protective cradle so she can't fall out. And on the wall is the usual range of technical equipment that the staff need to care for her. In this case, the nurse had been wearing a conventional face mask, but today he won't need that. Every nurse knows that their main concern is the welfare of the patient. But in an epidemic, it is very important that the staff avoid getting infected. So we'll surround the nurse's head in a plastic bubble-shaped chamber, which is fed with a supply of sterilised pure air through an air pipe running from a flexible connection at a point-of-use positive pressure air socket mounted on the wall. Nothing can ever get into the chamber. The nurse is completely insulated from pathogens in the air of the ward. And here is this revolutionary new equipment as it might be in use. Fresh air, filtered and sterilised by ultraviolet, is fed to the nurse through a tube running from the wall socket. The air enters through the air pipe, gently flows out of the chamber so the nurse remains safe. Air escapes from the lower rim of the chamber just as it does around a conventional mask. The spherical chamber gives protection from droplets, and the wearer is breathing pure, fresh air. But this won't work, and for several practical reasons. It's solid and claustrophobic. You can't wear your glasses, it muffles your voice. and it tends to mist up. Literally, back to the drawing board. We'll redraw the head. And we will protect him this time with an inexpensive, flexible, inflatable airbag. Now, we'll tear this off. Here it is. And replace the inflexible dome with the new plastic chamber. This version shows that it would be fixed under the chin with something like Velcro. We have created a surgical bonnet. It's Brian's version of a bonnet. It's a bonnet! Having a pneumatic air supply means you need an air pump, and that might seem to involve costly new technology. But suitable pneumatic systems are old hat. As a little boy, I recall stores having pneumatic tubes to send bills to the cashier, and I was very surprised to find a city-wide installation of a pneumatic mail system when I first went to Prague in the late 1960s. The system still exists, though it's been damaged by floods. Bulky packages in sealed cylinders were sent below ground through pneumatic mail pipes which connect to terminals in post offices. The pipes extend for 34 miles, 55 kilometres. And you will still find these rows of air pumps powering a mail system today in many modern hospitals, where they take prescriptions and medical samples from one department to another. If you have a close look at the sockets on the wall, you can see they have specially designed connectors that supply pressurized and purified air. Users could move from one wall socket to another with air tanks on trolleys. Divers use those already. I have other uses in mind for this pressurized air. It could power ventilators, making them less costly. It could inflate airbags to support patients or help them be turned over. It could be ducted into porous mattresses to manage pressure sores. And we ought to have an adapter to inflate balloons for parties. Right, it's time to try it out. We're going to need some plastic sheet, masking tape and foam tape, hook and eye strips, scissors, and of course my anatomical dissecting kit, which has all the instruments I might also need. So, let's see what a bonnet might look like, and then we'll find out if it works in practice. So, after some contingent modification and expedient improvisation, or farting about as we call it, we have a prototype bonnet, complete with its air supply and ready to put to the test. Popping it on is no effort at all, and it could be designed to fit easily under the chin, as any bonnet should. It means I'm completely sealed off from the outside world. It means that I have my own private air supply. It even means that I can continue to use a mobile phone if I want to. Hello, I'm terribly sorry, I think you have a wrong number. It means I cannot possibly acquire any outside germs. The nurse's view of the patient is unimpeded, and indeed the patient gets a pretty decent view of the nurse, and that can be very important in terms of personal contact, friendliness, and speedy recovery. In the close confines of a hospital ward, reflections will be much less of a problem. Why, I can even wear, and if I need to, adjust my own spectacles. It really is extremely easy to remove. So, this little prototype seems to work. Would it work in practice? Only time will tell. But if it does, you know, I honestly think that could solve an awful lot of pressing problems. We can solve the most immediate problem, however, by recognising the overwhelming importance of keeping the virus away from the general population. That's how the world can keep carrying on fairly normally and how commerce can continue to flourish during a pandemic. There is no need for a general lockdown. You need conscientious tracking and tracing and meticulous quarantine, and that is the way that life can go on in future even when a pandemic strikes. There are other things we could do. Saying that vaccination passports are discrimination just frees up people to kill. Of course they're important. Something else that would help would be the pooling of samples. That could allow you to locate one carrier out of hundreds with just a few tests. You could monitor sewage from a building to prove that it's still virus-free. And we should be vaccinated. Yes, a small number of people have died after vaccination. Ever since the first COVID-19 vaccination was administered in the United States, 18,720 people have died on the roads. I don't see anybody suggesting we should curtail traffic. Almost 1/3 have died of the after effects of a fatty and salty diet, and I don't see that changing much either. Believe me, in the modern world, vaccination is one of the safest things you could possibly do. Until we had the vaccine in Britain, the government was renting exhibition centres, equipping them as wards, and claimed they'd been building hospitals. Nightingale hospitals, they called them. But they didn't use them for the COVID-19 patients. They kept sending them to the general hospitals, so the disease just kept spreading. On April the 8th, 2020, I uploaded a personal plea to the British government, pleading with them to keep the virus away from the general public. And it also suggested they should stop exaggerating what they'd done. You've made a great play of the new Nightingale Hospital.
The new NHS hospital, built in just over a week in East London, has begun treating its first coronavirus patient.
No, wait, you haven't built anything. You equipped an exhibition centre as a hospital. That's a remarkable achievement, but don't diminish it by overstatement. In an earlier video, number 3, I think, I made these points. You can also catch it by the expedient of being in hospital with something else. There's a case to be made for all the COVID-19 patients to go to the special new hospitals. Putting them in ordinary hospitals means that people already ill are exposed to a second hazard, and that makes no sense at all. And yet if you turn on the news, this is what you'll hear.
The first patients arrived yesterday evening. A spokesperson for the Nightingale said there was still capacity available in other hospitals in London.
I think you misconstrue the benefits of the Nightingale Hospital. You regard it as an overflow for seriously ill patients. I regard it as an isolation hospital. The Nightingale Hospital should be full of patients. People should only go to the other hospitals, the specialist departments where they carry out these major and quite remarkable surgical achievements. They should only go there if there aren't any other beds anywhere else. At the present time, there are many patients in urgent need of organ transplants, of cancer treatment, of major surgery to prolong their lives. You don't take infected people and put them into a hospital where patients are already fighting for their lives. I urge you to redesignate the Nightingale and the other hospitals like it as isolation units to try and contain this highly contagious infection. Patients should only go to general hospitals, and particularly to departments dealing with urgent chemotherapy and urgent surgery, life-saving procedures which are currently halted. They should only go there as a last resort, and not as a first port of call. We have some of the best centres in the world for the treatment of cancer and for organ transplantation, and many of them are now idle because of the imminent threat of a virus infection. Patients, in many cases, simply cannot wait for treatment, and the last thing they want is a virus to add to their woes. I think these centres should be redesignated as virus-free centres of excellence. Truly, I believe something should be done about this, and I think it should be done today. Nothing was done, of course. Governments seek popularity, not solutions to long-term problems. I mean, to a politician, short term means within a few days. Medium term means within a month or so. Long term means by the time of the next election. To me, short term means over the next few weeks. Medium term means over the next few years. And long term means over the next generation or two. That's what I think about, but politicians know that governments are long gone by then. We know in science the importance of being prepared for the future. I was warning about a coronavirus epidemic more than a decade ago. Already there are strains of this new virus that cause gangrene. And if we're hit by a hemolytic virus of high infectivity, we need to act fast. Dithering politicians and self-serving experts could cost us dear. It is 50 years since I launched my successful campaign for the introduction of biohazard law, but the lessons have still not been learned.